Okay, so for our final example, we're still calculating the frequency for non-EM waves. So this is a seismic earthquake wave traveling at a velocity of 5,300 meters per second with a wavelength of 212 meters. And it wants us to calculate the frequency. So D stands for draw and Dilfsau, so we're going to draw our wave. We are able to label its wavelength at 212 meters. And we're going to list L, and Dilfsau is for list our variables, so we know that its velocity is 5,300 meters per second, and its wavelength is 212 meters, and we're calculating frequency. So we look at our triangle because the next thing we need is F, which is our formula. We look at our triangle and we can cover up the F because that's what we're solving for, and that leaves us with velocity and wavelength. So that means that we have a formula that is frequency is equal to velocity over wavelength. So now I fill in my known variables. So frequency is equal to 5,300 meters per second over our wavelength, which is 212 meters. Move this up a tad. Okay, so let's take a look at what we're going to do with our units. So my seconds, because it's at the bottom of this this division line, would actually be down at the bottom. And I have 1 meters on top and 1 meters on the bottom, which allows them to cross cancel. And since I have a seconds on the bottom, it's like a per second. And that means we're going to be ending up with hertz when we're all done. So we do the math. 5,300 divided by 212 is going to give me an answer of 25. And since I have per seconds, that gives me hertz as my final answer.